This is a good application for implicit because obviously I'm looking at a situation where this is not a relationship. This is not in a y equals form, but it is a curve, so it does have slope. So this is a good opportunity for us to practice our implicit. First, we're going to find dy dx. So of course, I am going to do this implicitly. So I'm going to have 3y squared dy dx plus 2y dy dx minus 5. Be careful on these because there was still a y there, so I still have to have a dy dx. And this, of course, is going to be minus 2x. I could have put a dx there, but that is just 1, so I'm not going to include that. And then, of course, it's equal to 0. Also, please be careful with that. That is a very common error for kids to forget to take the derivative of the constant. I'm going to move the 2x over, then I'm going to factor out a dy dx from all of these other terms. Then I would have added 2x to the other side. So my last step is just the division piece. So dy dx is equal to 2x divided by 3y squared plus 2y minus 5. So that is the equation that's going to represent slope at any point I want on that curve, but it is not a function. The next thing I'm going to do is I'm going to write the equation of the tangent line at the point 1, -3. This is a good reminder for our notation whenever we do implicit at a specific point. So we have dy dx such that x is equal to 1 and y is equal to 3. So I usually just write that as the ordered pair. And then I'm going to plug in a 1 everywhere I see an x. I'm going to plug in a -3 everywhere. Oh, I wrote the wrong thing down. I'm going to plug in a -3 everywhere I see a y. So plus 2 times -3, then minus 5. Then I just need to do a little bit of simplification. So of course the top is 2. The denominator, this is going to be 18. Oops, sorry. 18, then minus 6. And then, oh, I'm sorry, that's right. So this is going to be 27 minus 6 minus 5. I just went a little quick there. So that should be 16. 27 minus 11. So that does reduce to 1/8. Now I have my slope, but this did not just ask me for slope. It asked me for the equation of the tangent line. So now I have to go to my point slope form. Y minus a -3, so that does become a plus. So I'm going to skip that little step there. Then 1/8 x minus 1. So there's your equation of the tangent line. So the last example is something that you're going to be expected to do relatively regularly. So find the coordinates on the curve where the line tangent to the curve is vertical. Okay, let's take a look at our picture before we start looking at all of the math and the algebra and the analytics of this. If I were to draw a vertical tangent line, I could look at this graph and go, okay, I can kind of see that right there would have a vertical tangent line. And then I would also have another one. I would have another one over here and over here. So there's a total of 4 points that I'm going to be working with. But there is a little bit of symmetry involved to this curve. So I'm hoping that the symmetry helps me out just a little bit. But I am going to be looking for 4 points. So how does this work? Well, let's take a look at the derivative first of all. When I did this, if I'm looking for where I have a vertical tangent line, ultimately I'm looking for where the derivative is undefined. So I want to know where this bottom piece is going to be equal to 0. Because if I have something divided by 0, I'm going to end up with an undefined slope. So let's make a note of that. So we've got vertical tangent occur, tangents, I'll put that, occur where deriv is undefined. Therefore, where denominator equals 0. So working with a fractional piece here, I'm working where the denominator is equal to 0. So I'm going to go ahead and write that denominator down. I've got 3y squared plus 2y minus 5 equals 0. That's what I'm trying to solve for. If I had a calculator, I might be able to use just the graph to find these zeros, but this does factor. This factors into 3y plus 5 and y minus 1. So I'm looking at when y is equal to negative 5/3 and when y is equal to 1. But remember, there are 4 points. So I can't just stop there. I have to find the x's that correlate to these y values. So if I'm going to go find the x's, I'm going to take this y value and I'm going to plug it into the original function. If I plug it into the derivative, it's not going to help me. It's just going to give me an undefined answer. But if I plug it into the original function, then I can find the x that goes with it. So let's see if we can figure out where these 4 points come from. I'm going to start with the y part, with the 1 part. So y cubed plus y squared minus 5y minus x squared. Okay, so that's going to be my original function. Now let's take that 1 and plug it in. So 1 cubed plus 1 squared minus 5 times 1 minus x squared equals negative 4. Well, now this is just solving, right? So I've got 1 plus 1 minus 5. So that's going to be negative 3. Then I'm going to add the 3 over to the other side. When I add that 3, I end up with a negative 1. If I divide both sides by negative 1, that gets a little easier. I've got x squared is equal to 1, right? So that doesn't mean that x is just 1. It means that x is plus or minus 1. So the points for my vertical tangency are going to be 1, 1, because the y is always 1, and negative 1, 1. Well, let's go back and look at our curve to see if that makes sense. So it looks as though I've got, yep, there's 1, 1, and there's negative 1, 1. Okay, so I'm feeling pretty good about my math so far. But this part is going to be a little different. Okay, I have my y as negative 5/3. So my y would be right in here, negative 5/3. Okay, that makes sense. But I need to find the x values, right, that go with those. And this is going to be a little bit more complex. So it's going to take a little bit more work because the negative 5/3. So I'm going to plug in negative 5/3 everywhere I see a y. So minus negative 5/3 squared minus 5 times negative 5/3. Oh goodness, this is getting a little scary looking. So of course, using a calculator would make this a whole lot simpler. I would much prefer to use a calculator in order to be able to solve this. But I just kind of wanted to take you through some of the ways that we could simplify this by hand. And then at the end, we'll use a calculator to help us. But could I do this by hand is kind of my question. And I really should be able to. This is negative 5 cubed over 3 cubed. So I'm looking at negative 125 over 27. And then I am going to do subtraction here because when I multiply a negative times a negative, I'm going to get a positive. So that's going to be, oh, I'm sorry, I wrote down the equation wrong, didn't I? So this was supposed to be a plus. I went a little bit too fast there. So this is going to end up with a plus. And this is going to be 25 over 9. Right? And then I'm just multiplying 5 through. So plus 25 over 3. Then I've got minus x squared is equal to negative 4. That looks pretty intimidating, just sitting there as is, but the common denominator piece isn't going to be super hard. The 27 is going to be the common denominator. So if I multiply those by 3, and if I multiply that times 9 and that times 9, I'm going to get the common denominator that I want. I just have to deal with the x squared. So let's go back. I'm going to end up with negative 125 plus 75 plus, and then 25 times 9 is 225. All of that is over 27, and I still have the minus x squared. So just a little bit of simplification here. You end up with, let's see here, negative 125 plus 75, that's negative 50 plus 225. So I've got 175 divided by 27. Too bad that doesn't reduce to an integer. That would have been nice. Is equal to negative 4. So now let's go ahead and subtract that piece over. Right? So I'm going to subtract 175 over 27. And now I'm going to subtract 175 over 27 here. And that negative 4 is going to certainly come into play, right? The negative 4 is negative 108 over 27. So 27 times 4 if I wanted to get that common denominator. So what I have here is negative x squared equals negative 283 over 27. That is negative 108 minus 175 is what that is. So again, they're both negative. So this is what I've got, right? So x is equal to the plus or minus root of 287 over 27. So that is the exact answer. Obviously, you could put this in the calculator and get a decimal. You could have used the calculator up here if you had access to one. But I wanted you to see that this was possible. Now let's take another step. I don't really know exactly what that value is, but 287 divided by 27 is a little bit over 10, right? So 27 times 10 is 270. So this is, about 10 and a half-ish, right? Not exactly, but I'm getting close to that. So when I root that, it should be a little bit over 3. Well, that's what I have here, right? The root of 10, the root of 9 is 3, right? So the root of 10 would be a little bit over 3. So I'm at the positive 3 and a little bit, and then negative 3 and a little bit. But I do like having this exact answer, and I thought it was worth going through. So the points, again, of vertical tangency are going to be the negative root 287 over 27, and then you're going to have a negative 5/3 is the y value, right? And then the positive root 287 over 27, and then a negative 5/3. So these are your 4 points right here of vertical tangency, and that is where the denominator of your derivative is equal to 0.